please have your notes out for C. I'm aiming for complete the 2 exercise today, so for C and for D. For D is actually not on the book, is a supplementary course. Okay. So for C's title is not actually correct. So I would say this is a square root function. So for square root function, how we can sketch square root function? So what is a square root function? So square root function have the simplest form. Y equals to square root x. Y equals to square root x. Think about the domain for this function. Everything you put into the square root, under the square root, that value should be greater than 0. So the x should be greater than or equals to 0. So x needs to be greater or equals to 0 in order to put under the square root. Otherwise, say square root -4, that's not going to work. It's not a real value. So the value you put under the square root must be greater or equals to 0. Therefore, you have the domain. You have the domain R plus union 0. R plus union 0. Because R plus is not including 0, it's everything to the right of 0. Union 0, you put the 0 back. Or you can write in this way. Okay, I would prefer this way. 0 to infinity. 0 to infinity. Start from 0. Everything else to the right hand side of 0 will be possible. So 0 to infinity. So what is the range? Square root a positive number is always positive number as well. So the range is still the same. R plus union 0, you can still write that into 0 to infinity form. 0 to infinity form. Okay, so same as the previous 2 equations, we have the simplest form. The simplest form for hyperbola will be 1 over x, for truncus will be 1 over x squared, and then we learn the general form. So what is the general form for square root function? The general form for the square root function will be a times square root m bracket x minus h plus k. Okay, we have a lot of values. We have a, we have n, we have h, and we have k. So let's have a think about what's the use of these numbers. Go back to the simplest equation. Okay, y equals to square root x. What you can see from this equation, you can see this graph stop at this point. Okay, the left hand side stop at 0, 0 and keep going. Okay, the right hand side keep going. So I will say I have an endpoint. I have an endpoint at 0, 0. Okay, I have an endpoint at 0, 0. So I stop this part and then I go forever to the right hand side. So let's go back to the general form. Okay, first, what A do? A is a dilation factor from the x-axis, and then it will be reflected in the x-axis if A is smaller than 0. Okay, there will be a reflection. Remember, there will be a reflection in the x-axis if A is smaller than 0. Okay, what's the n do? What's the n do? 1 over n is a dilation factor from the y-axis. I don't really care about how much I have stretched this graph, but I care about the reflection. So if n is smaller than 0, I will have a reflection in the y-axis. Okay, there will be a reflection in the y-axis if n is smaller than 0. That's the 2 things I need to worry about. Okay, that's the key thing I need to worry about. Okay, h and k is horizontal and vertical translation, up or left. Okay, so the endpoint, think about I have the endpoints. Okay, I move to the right, the endpoints will move to the right. I move down, the endpoint will together move down. So the new endpoints is h and k. That is important. We always need to find h and k first. Okay, so first step, find endpoint. Okay, first step, find endpoint. Second, what are we going to do? Find the shape. Okay, what do I mean by find the shape? Okay, what do I mean by find the shape? Let's draw four graphs. Let's draw four things. Okay, the first one is square root x. Square root x looks like this. Square root x looks like this. Okay, how about if it's a square root negative x? How about if it's a square root negative x? Okay, my x needs to be negative. Because it's a negative, so I put a negative together with x. That will be reflected in the y-axis. Okay, in the y-axis. So the graph will look like this. Okay, we'll go that way if you have a negative inside. How about if it's a negative square root x? You have a negative outside the square root. The graph will be reflected by the x-axis because it treated as a is negative. A is negative. So reflect in the x-axis. My graph will look like this. Okay. If I have two negative. Negative root negative x. Okay, if I have this, then the graph will be the original graph, reflect in the x once and then reflect in the y again. So the graph will look like this. Okay, it's actually four direction. It's actually four direction of this graph. Okay, you will choose one of this shape. Okay, you choose one of this shape. So if I can put it here. If I can put it here. Okay, so it's basically that direction, that direction, that direction, and that direction. That one is root x. That one is reflect in the y-axis, so it will be square root negative x. And that is a negative square root x. Not this one. Negative root square root x. And then the last one is negative square root negative x. Okay, it's four direction. It's four direction. You will only choose one of this shape. Okay, you only choose one of this shape. You will look at a is negative or n is negative. Okay, you look a is negative or n is negative, or both positive or both negative, and you will choose that. So for this one, a and n are both positive. Okay, for this one, a smaller than 0, n greater than 0. For this one, a smaller than 0, n smaller than 0. For this one, a greater than 0, n smaller than 0. Okay. Okay, that's the shape, how we can choose one of this shape. You look at a and n value, see which one is positive, which one is negative, and you choose from this shape. Okay? So first step, make sure where is your endpoint. The second step, find the shape. And the third step will be find xy intercept. Find as xy intercept. So find intercept. Okay, find intercept. Okay, for example 1, let's have a look at example 1. For example 1, okay, so if I compare to this, I will say y, change the color, y equals to a square root n x minus h plus k. Okay, I want this form. So fx can equals to 1 times square root 1 times bracket x minus negative 1 minus 3. Okay, so it's a plus negative 3. Okay, that's a plus negative 3. So what is the h and k value? So a equals to n equals to 1, h equals to negative 1, k equals to negative 3. Okay, that's the value. That's the value. So So what is the endpoint? Endpoint will be h comma k, h comma k. So it's -1, -3. -1 and -3. So let's draw this. Okay, so that is y, that is x. I want -1, -3 to be the endpoint. Okay, here is my endpoint. Here is my endpoint. -1, -3. And then that's the first step. What's the second step? Find the shape of this graph. Find the shape of this graph. So originally the graph should look like this. And if both positive, okay, they're both positive. A is and N or both positive. So your graph will, that is the endpoint, the graph will be an increasing graph to the right. So roughly sketch, you have a graph looks like this. Okay, roughly sketching, you have a graph look like this because the shape is increasing and then to the right hand side will be the same shape as this one. Roughly looking, it looks like this. And you can see you have the x-intercept and you have a y-intercept. So you are trying to work out the x-y intercept to make an accurate graph, So let's do when x equals to 0. Y will equals to 0 plus 1 minus 3, which gives you y equals to -2. Y will equals to -2. I will take okay, -2 is here. That's a -2. So that's a 0, comma -2. When y equals to 0, when y equals to 0, that equals to 0. Square root x plus 1 equals to 3. Okay, square root x plus 1 equals to 3. Therefore, x plus 1 equals to 9. X plus 1 equals to 9. Your x needs to be 8. Your x needs to be 8. So 8, 0 will be another point. 8, 0 will be another point. Okay, my scale is not very well, so okay, I will resketch this. Okay, so 8, 0. So let's say 8, 0 is here. And I have 0, -2. 0, -2, and -1 and -3 is the endpoints. So -1, -3. Okay, -1, -3. And then if I can connect all these points, you need to show the endpoint, okay? You need to show the endpoint. You need to really sketch a circle, like a closed circle here. Okay, make it clear that's an endpoint, okay? That's an endpoint. And label your endpoints. Your endpoints is a key feature. Your endpoints is a key feature. Every time, like if your graph stop at a particular point, you need to label that. So you need to label x, y intercept. You need to label endpoints. You need to label any asymptotes, okay, and any turning point. Any turning point. Okay, so that is my graph. That is my graph. Okay, let's go for the next one. Okay, fx equals to 1 minus 2 square root x plus 1. Okay, so if I make it fx equals to minus 2 square root x plus 1 plus 1. Okay. So not a plus 1, let's make a minus negative 1, if that makes sense. Minus a negative 1. So h will equals to minus 1, k will equals to 1. A will equals to negative 2 and n will equals to 1. Okay, that's how this value works. Because x is positive, so your n will equals to 1. Okay, why I'm not asking you to find xy intercept first? Because some of the time, this graph may not have xy intercept. Do not waste your time. Let's have a look about what's the general shape of your graph. And then to confirm, okay, there is an x-intercept, there is a y-intercept, and then we start to calculate that. Otherwise, you waste your time. So I will still try to find the general shape of your graph. Okay, let's have a think about the general shape. I'm not going to sketch it, but think about here. H and K, negative 1 and 1. You have the graph like the endpoint here. And then the original graph looks like this. You have a negative A, but positive N. So the graph, okay, the negative is outside the square root. Therefore, the graph is reflected in the x-axis. Then the new graph will look like this. Okay, this is the new graph. This should be the shape of your graph because they only reflect once and it's reflected by the x-axis. A is negative, so it's reflected by the x-axis. So your graph will be some shape looks like this. Okay, that will be the shape of your graph, like a rough shape. And you can see there is an x-intercept and there is a y-intercept. So you will try to find them out. So you will say when x equals to 0. Y equals to 1 minus 2 square root 1. Therefore, y equals to negative 1. So 0, negative 1 will be one of the x-intercept. Okay, it's not one of, only one x-intercept. So that's the x-intercept. When y equals to 0, 1 minus 2 square root x plus 1 equals to 0. 1 equals to 2 square root x plus 1. A half equals to square root x plus 1, which will give you a quarter will equals to x plus 1. Okay, a quarter will equals to x plus 1, which will give you x equals to negative 3 on 4. Negative 3 on 4. So negative 3 on 4, comma 0 will be the x-intercept. Will be the x-intercept. And 0, negative 1 is the y-intercept. And now we can start to sketch it. I will just take off this one. And then I will make that larger. So okay, so the first point is h, comma k, so negative 1 and 1. So negative 1, 1 is here. Not here. Negative 1 is on the top. Negative 1 and 1. Okay, negative 1 and 1 is here. And then you have 0, negative 1, which is here. 0, negative 1 is here. And you have negative 3 over 4. Okay, 0.75, which is here. Okay, so the graph will look like this. Okay, that is the graph. Okay, shape looks like this. And then you will label the xy intercept. Here is -3/4, comma 0, and here is 0, -1. Okay, and then that is your endpoints. Label your endpoints clearly. Okay, with a closed circle, that is your endpoints. Oh, okay, one thing I forgot to talk about. Let's go back to the first exercise. One thing I forgot to talk about, which is the domain and range for the function. Okay, which is the domain and range for the function. I will write here. Okay, what is the domain? Okay, the domain is all the x you can take. You can see if I sketch a dashed line here, okay? Everything to the right of the dashed line, you have a function. To the left, you don't have a function. So which means all the x to the right of this dashed line is possible to get. So -1 is the farthest endpoint. So the domain will be -1 to infinity. Everything to the right-hand side of -1, you can take them. Okay, but look at this graph. Everything to the right-hand side of -1, you can take them. So it's -1 to infinity, which you can include -1. What is the range? What is the range? Okay, if I sketch another dashed line here, you don't have any graph below that. You have all the graph above that. Okay, you can take everything above this line, but you don't have any graph below this line. So this line is -3, which means you will start with -3 and goes to infinity. Okay, goes to infinity. That is the domain and range for this function. Domain and range for this function. Okay, let's go to this one. What's the domain and range for this one? Okay, still if I sketch a dashed line here, to the right of this dashed line, you can take values. This dashed line is x equals to -1. So everything to the right-hand side of -1, you can take. And what is the range? If you sketch another horizontal dashed line here, you can think everything below that you can take, not above. You don't have any graph above that. So which means your ranges start from -infinity, because all the farthest below end you can take. You can take everything below until you reach the point 1. You can reach the value 1. Okay, -1 and 1. This black dashed line is y equals to 1. So you can take until 1. Everything just below that is possible, not above that. So it's -infinity to 1. Okay, -infinity to 1. Domain and range is best to be found by looking at the graph. If you can sketch the graph first and then think about the domain and range, that would be great. Okay, that would be great. Okay, next question. Okay, for this one, I will suggest you to put every function into the standard form first. Put into the standard form first. So that one is fx equals to -2 square root. Okay, 5 minus x. I'm not happy about that. I need x to be in the front. So it's a -x minus 5. And then +1. Okay, I'm happy about this format. So, what are the values? A equals to -2. N equals to -1. H equals to 5. K equals to 1. So 5 and 1 will be the endpoint. 5 and 1 will be the endpoint. Okay, 5 and 1 is here. And what's the shape of this graph? Okay, what's the shape of this graph? You have two negative, right? You have two negative. You have A and N, they're both negative. So the original graph look like this. You have two negative, which means you will reflect by X and reflect by Y. So if you reflect by X, you will look like this. If you then reflect by Y, the final one will look like this. That's the red one, okay? That's the red one. So your graph is actually look like this. Your graph is actually look like this. Okay, roughly look like this. So what's the XY intercept? When X equals to 0, Y will equals to 1 minus square root 2, 5. And that's it. You can't simplify any further. But what's this value? Is that a value, like, which this value around? Okay, think about square root 5. Think about square root 5. Square root 5 must be in between square root 4 and square root 9, right? So square root 5 is a value in between 2 and 3. That will be a value in between 2 and 3. That's how you're testing a value, okay? You have a rough idea about this point. So you have 1 minus 2 square root 5. So what is 2 square root 5? 2 square root 5 will be in between 4 and 6. In between 4 and 6. And then you have 1 minus 2 root 5. So 1 minus a number in between 4 and 6. In between 4 and 6. So 1 minus 4 give you negative 3. 1 minus 6 give you negative 5. So 1 minus 2 root 5 will be in between negative 5 and negative 3. Okay? This value, 1 minus 2 root 5, will be in between negative 5 and negative 3. Okay? You roughly know where it's about. It's below the x-axis. It's below the x-axis. Negative 5 to negative 3. Okay, so when y equals to 0, when y equals to 0, 1 minus 2 root 5 minus x equals to 0. Y equals to 2 root 5 minus x. A half equals to square root 5 minus x. Square both sides. A quarter equals to 5 minus x. X will equals to y 5 minus a quarter. Move the x to left, move a quarter to the right. And then x equals to 5 is 20 over 4 is 19 over 4. Okay, it's 19 over 4. X equals to, so 4.75. 4.75. Okay, 4.750 is the x-intercept. Is the x-intercept. And let's sketch it. Let's sketch it. I will take off this. Okay, so the endpoints is 5 and 1. Which is here. And then the x-intercept is 4.75, which is somewhere here. And then the y-intercept is in between negative 3 and negative 5. In between negative 3 and negative 5. So let's just roughly, so negative 3 is here, negative 5 is here. So let's make a value in between. So let's say it's here. So remember the shape. So originally it looked like this. roughly should look like this. Okay, that will be the graph. It's not looks good. It's here. Okay, that's the graph. That's the graph. So you need to label all of these. So this point is 5 and 1. That point is 19 over 4, comma 0. Huh. Okay, here is 19 over 4, comma 0. And here is 0, comma 2 root 1 minus 2 root 5. 1 minus 2 root 5. Okay, that is the graph. That is the graph. And what's the domain and range for this graph? What is the domain and range for this graph? Okay, domain. Okay. Everything to the left of this red line you can take, okay, to the left. So you can take everything to the left. Then it will start from negative infinity until the point 5. Okay, until you reach x equals to 5, that vertical line. And what is the range? What is the range? Okay, let's sketch this line. Everything below this blue line you can take. So still start from negative infinity until you reach the value 1. Until you reach the value 1. Negative infinity to 1. Okay, start from the smallest to the largest. So you can take everything below and until you reach the value 1. Okay, move on. You have fx equals to 3 plus 4 minus 2x. Okay, that's not in the standard form, so what we can do, we can make fx equals to square root. I want x to be in the front, so it's minus 2x minus 2. Okay, bracket, and I want to take a common factor. I want x to be single by itself. And then plus 3. Therefore, I have a equals to 1. Okay, I don't have anything outside, so it's 1. So n equals to negative 2. H equals to 2, k equals to 3. H equals to 2 and k equals to 3, minus h plus k. And then I will have my endpoints at 2, 3. Okay, that is the endpoint. That is the endpoint. And then what's the shape of this graph? What's the shape? Original shape like this. You have n is negative. N is negative means the thing in the square root is negative. Combined with x is negative. Therefore, I need to reflect by the y-axis. Okay, I'm changing x, so I need to reflect by the y-axis. Then the final graph will look like this red one. Okay, that is the shape of my graph. Because my endpoint is here, so the shape of the graph will look like this. Okay, go that way. And you can see, amazing, we don't have x-intercept. Save us some time. I only have one y-intercept. Okay, I only have one y-intercept. So let's just look at the y-intercept. To look at y-intercept, I will make x equals to 0. So when x equals to 0, y will equals to 3 plus square root 4. Y will equals to 5. Square root 4 is 2, 2 plus 3 is 5. Therefore, 0, 5 will be the y-intercept. Okay, so let's sketch it. I'll take off this. Give us enough space. Anita? Toss over there. Okay, so come back. Let's do this. Okay, let's say that's x, that's y. I have 2 and 3 to be the endpoints. So 2 and 3 is here. And my y-intercept is 0, 5. 0, 5 is here. Okay, 0, 5 is here. So the graph will be like this. I want to change the color. Okay, so this point is 2, 3. That point is 0, 5. Okay, 0, 5. That is the graph. So I don't need to find x-intercept because there's no x-intercept. That's why I tell you, find the rough shape first and then decide, do you want to find x-y-intercept? Sometimes we don't have x-intercept, we don't need to find it. Okay, so directly go up. Start from that point, go up. I don't have x-intercept. So what is the domain and range? Think about the domain. Okay, domain, let's sketch a vertical line. So the vertical line is always trying to find domain. So everything to the left of this red line will be the domain. So the domain will start from negative infinity until where? Until the value 2. Okay, that's a 2. Until you reach this vertical line. Okay, for range, you don't need to show the dashed line on the paper, okay? You don't need to show it. I'm just teach you, so I show it. So everything above this blue line is possible to take, okay? All the y values above this blue line is possible to take. So the range will start with 3 until infinity. Until infinity. So start from 3, go forever. So 3 to infinity. That's the domain and range.